Welcome, students, to day 342 of this coronavirus homeschooling chaos that we are doing. Professor Muggleworth's today at your service, and Ms. Maneri tells me that you are learning about how to solve log equations. So today we are going to begin learning about logs. Good heavens, children. I don't know how to do any of this. I think I'm just gonna get somebody who does.
Hey everybody, Miss Professor Muggleworth said he didn't know how to do logs, so I am here today to help you guys learn how to solve these log equations. I hope you guys are doing well and surviving this. So we're going to do a lot like we did with solving exponential equations. You know how to go back and forth and you know how to solve equations, so I really expect y'all to do well on these. Even though it has a log, we now are feeling comfortable with what logs do. So let's dive in. I am going to work the left-hand column of the note examples, and then you can use the right-hand column as a practice question to do all your own. All of these answers are on my Canvas page, so you can check to make sure that you worked these questions in the right-hand column correctly on your own if you would like the extra practice. All right, so let's dive in. I see here I have an equation. Remember, this part is called the argument. When we are looking for extraneous solutions today, be sure that the argument is never negative. The reason that is because remember what a log actually represents. If I, for example, have this, I know that the question this is answering is 3 to what power is 9? Well, 3 squared is 9. So if you remember what a log means, it makes no sense ever to have a negative argument because, make sure you can see this, 3 to what power is going to give me negative 9? Well, I can hear some of y'all out there, you're saying, oh, Miss Mary, what about negative 2? Well, what is 3 to the negative 2 power? Remember, negative powers mean the reciprocal, so that would actually be 1/9, not negative 9. So, what else could we try? Even if we tried a half, that's taking the square root. So there's nothing that I can raise it to the power of and end up with a negative number, okay? So keep in mind, whenever we have a negative argument, that means we're going to be having an extraneous solution. It is not a solution. It is not possible to have a negative argument. There is no solution to that. So that's one thing we're going to be looking for today. Okay, there's not much I can evaluate as is, but I'm going to go ahead and convert it into exponential form to see if that will help us solve it. So remember, base stays the base, and this is going to become our exponent. So base stays the base, and the other switch place. This should be a 9. It's kind of hard to read. Okay, so 3 to the 4th. Remember, that's 3 times 3, which is 9. And I got 9 times 9 is 81. So 3 to the 4th is 81. And I'm going to go ahead and distribute this, 9x and 18. You also could just divide by 9. You're going to end up the same place. But either way you decide to solve this is fine. In fact, that looks a little bit easier. I'm going to try it that way instead. I could subtract 18 and divide by 9. But what if I divide by 9 here? I am left with... So 81 divided by 9 is 9 equals x plus 2. Subtract 2, and I get 7. So here's where I'm going to check to make sure it's not extraneous. I'm going to plug 7 in for x. So that's 9 times 9 is 81. So I have a positive argument. It should be correct. Well, 3 to the 4th is 81. So my solution is valid, but that is how you can plug it in and verify that you got it correct. Okay, if you would like to pause the video and try this one on your own, feel free to, or I'm going to plow ahead with the rest of the notes. Okay, again, I'm going to transform this into exponential notation to help me see it better. So I have a base of x, an exponent of negative 2 equals 4/9. Now, remember what a negative exponent does. That takes the reciprocal of it. If I want to get rid of this negative 2, remember I'm really trying to get x by itself. To get rid of it, I could raise this to the negative 1/2 power. The reasoning is a negative times negative is going to give me a positive, and 2 times 1/2 is just 1. So I'm getting x by itself. What I do to one side, I have to do to the other side. Algebra is very fair like that. And remember, to get rid of this negative, that's going to be the reciprocal. So if I want to get rid of that, I can take the reciprocal, and now the negative is gone. What does something to the 1/2 power mean? Well, remember, that means the same as taking the square root. So the square root of 9 is 3, and the square root of 4 is 2. So my answer is 3/2. Very good. All right, let's look at our next example. On this one, I have no x's over here. Everything is equal to x, so I really don't need to do algebra. I can really just think about, what does this equal? Well, the easiest part to start with is this part. What does this evaluate to? Oh, I sort of did that example already. This is asking 9 to what power is going to equal 3? That's the question. Well, 9 squared is 81, so I'm going the wrong direction. How do I go the other direction? Well, I know that the square root of 9 is 3. So what if I raised it to the 1/2 power, because that's the same thing as taking the square root. So 9 to the 1/2 power is 3. So this whole thing equals 1/2 power. And then I'm going to bring down that 4 that I haven't done anything with yet. And 4 times 1/2 is just 2. So that all equals 2. And you could type this into your calculator to verify that you did it correctly, just to make sure. All right, moving on. Next example. All right, this one again, I am ready to go ahead and convert it into exponential form. Base stays the base, and the others switch place. All right, 2 to the third. 2 times 2 is 4. 4 times 2 is 8. All right, how do I get rid of a square root? Take the square of both sides. 8 squared is 64, and now that square is canceling that square root, so I'm just left with x plus 5. All right, last I'm going to subtract 5, therefore x is 59. It sure is a strange thing, teaching a camera all these days. I will be so thankful when I get to teach actual students again in person. I'm like answering my own questions here. I know I sound a little crazy. I'm feeling a little crazy, truthfully, because this is a weird time to be teaching constantly this camera, and I'm seeing you guys out there, but it is a whole different experience doing it this way. I miss you guys. All right, number whatever we're on here, we are going to solve for x again here. I'm going to convert it to exponential form, so 5 cubed, base stays the base, the others switch place. All right, so in order to get rid of this 2, notice this means divided by. So to undo that division, I'm going to multiply both sides by 2. 5 cubed. 5 times 5 is 25. What's 25 times 5? 125. 125 times 2 should be 250. Well, that's it. That one wasn't too bad. All right, and just to be sure you're plugging your answers back in to make sure that they actually work. 250 divided by 2 is 125. And 5 cubed is 125, so it does work. But you always want to be checking. That's a way to make sure that you're getting your answers correct. If you can plug it back in and it works, you're good to go. Okay, this is a good example on the next one. Remember in the last unit, last lesson, last week, whenever we had something with the same base. For example, if I had something that was like 2 to the x equals 2 to the x plus 4. You knew that if the bases were the same, you could drop the bases and set the exponents equal to each other. Well, logs are also exponents because we can go back and forth between log and exponential form. Therefore, the same rule applies. If you have logs of the same base that are set equal to each other, just like this example, you can drop the base. These are both log base 10. Remember, 10 is implied if there's no base here. So therefore, since I have log base 10 on both sides of the equal sign, and all of this is an argument of both of them, I can drop the logs and set what the arguments equal to each other. So this is going to be just this. That's what we're left with. Okay, so now we're ready to just solve for x that we know how to do. Notice I have an x squared value, which means I'm going to need to end up factoring in order to be able to solve this, or use one of our quadratic methods for solving. So I'm going to get it equal to 0. I'm going to subtract the 4x and subtract the 6. I'm getting it equal to 0. And I combine my like terms, and now it's equal to 0. All right, so you're going to factor. I'm looking for two numbers. Since a is 1, I do not need to do the box. I can shortcut it. I know it's going to be x times x is x squared. I need two numbers that multiply to 7 and add to 8. Well, there's only one thing that multiplies to 7. It is 7 and 1, and those do add to 8. So I already have my factors. Now to get the solutions, remember we use the zero product property. We set these equal to 0. One answer is -7 and one is -1. I'm going to check to make sure that there's no extraneous solutions here. So when I plug in -7, you have to do it to both sides, but I'm going to try this one first. 4 times -7 is -28. -28 plus 6 is going to give me a negative answer. So I already know that this is an extraneous solution. It is not going to work because I'm ending up with a negative argument here. Let's try -1. 4 times -1 is -4, plus 6 is 2. So we are okay there. That is a positive argument. Plug in -1 here. When I square -1, I get a positive 1. So 1 plus -12, after I plug that in, so we're up to a -11, plus 13 is going to bring us to a positive 2. So the -1 works on both sides, but the -7 is going to be extraneous because when we plug it in, it causes us to have a negative argument. And if you type that into your calculator, you would also notice it's going to give you an error because, and I even think it gives you the error that it says negative argument. So be on the lookout for those. Occasionally when you plug them back into logs, it's going to give you an error for that message. So be on the lookout for those. Okay, next example. Ooh, we have a lot of extra logs here. But log of 10, what does that equal? Well, this is a base of 10. So 10 to what power equals 10? Oops, I'm giving it away. It's fun. So this whole thing equals 1. So really, that's really easy because if I have a 1 down here, really there's no denominator there at all. So it's kind of, they're trying to make it look complicated, but this really isn't that hard of a problem. Really what we're left with is log base 2. Because this equals 1, really it doesn't mean anything in our problem. Okay, now I'm going to convert it into exponential form. So I have a base of 2, exponent of 3, and I'm going to put the rest there. Okay, 2 to the third is 8. 2 times 2 times 2 is 8. And I have a quadratic again, I noticed, so I'm going to need to get it equal to 0. Therefore, I can factor it. So when I subtract the 8, I'm going to get a -12, and I'm going to bring everything else down. So when I factored, I'm looking, again, I have an x squared. So I'm going to have to bring it up here. I know it can be x times x is x squared. I need two numbers that multiply to -12 and add to 4. So I know that 6 and 2, a positive 6 and a -2. That multiplies to 12 and adds to 4. All right, therefore my solutions are -6 and positive 2. So let's check to make sure we don't have extraneous solutions here. If I plug in 2, 2 squared is 4, plus 8 minus 4, we're good. That's going to be positive. I'm going to try negative 6, I'm sorry. Negative 6 squared is 36. That will be a negative 24 minus 4. Yep, that'll be negative 28 from 36. That'll give me a positive answer also. So both of these solutions are valid. We have no extraneous solutions. So the negative numbers sometimes work. You just always have to plug it back in and check to make sure that it's going to be a valid solution. Okay, let's try our last two real-world problems and we will be done. The population of Whoville has been decreasing at a rate of 3.8% per year since Dr. Seuss passed away in 1991. Poor Whoville. When the population was 18,500, find the year when the Who population will be down to 2. So this is a per year scenario. So the formula that we're going to use is this one because it's saying it's an annual decrease. So we're wanting to know when the population is going to be down to 2. So that's a final amount. The current population is 18,500. And the population is decreasing, therefore I'm using a minus. Remember, we turn our rate into a decimal place with a t of time. Find the year when the Who population will be down to 2. Yeah, so we're trying to find how many years later from 1991. That's our beginning year. We're going to figure out how many years it took to get down to there. Okay, so to solve this, let's see. The easiest thing to start with would be to divide this. Oops. 18.5. Divide by 18.5. So I'm going to grab my calculator here. 1 minus 0.038 is I'm just subtracting these two numbers, 962. I still have my exponent of t. And this comes out to be, yikes, a gross number. I'm going to leave it like that. It's giving me like a huge decimal, and so it's easier for me to leave it like this for the time being. All right, I'm going to convert it into log form because I need to solve for t here. So log base of 0.962 equals t. So when I do this calculation in my calculator, I will know how many years later. So I'm going to type that in. I'm using an older calculator, so I'm doing the change of base formula. I'm going to do log of 2 divided by 18.5 divided by log of 0.962. Okay, so 230, I'm going to round down because they want to know how many years, they want to know in what year. Well, 235 and change years later is when the population is going to be down to 2. So it's approximately 235 years later. So if we started in 1991, 235 years later would be the year 2226. So somewhere in the year 2226, the Who population will be down to 2. Good thing we haven't reached it yet, so we can still make more movies about the Who's. Otherwise, we would be really concerned. But we still got a few more years to go, guys. We're good. Okay. Last question about titanium. Dr. McLeod will be excited that we're doing half-lives of titanium, right? So titanium has a half-life of 63 years. How long will it take for 400 grams of titanium-44 to decay to 80 grams? So the formula, we're going to be using the same formula that we used in the last problem. How long will it take for 400 grams? So 400 is an initial amount. Well, if it's halving, it's going down by half. And that means I'm going down by half each time. They're talking about a half-life here. And we're wondering how long it's going to take to get down to 80. So that's a final amount. We're trying to figure out how long, so we're calculating the time. All right, so we have 400 times, when I subtract those, I'm going to get 0.5. I'm going to divide by 400. So 8 over 40. 0.2. I should have known that. All right, so now I have something that I can convert into log form. So this is going to be log, base stays the base, and the others switch place. So I'm going to type this into my calculator. So I'm going to type, I have an old calculator, so I'm doing change of base formula. I'm going to do log of 0.2 divided by log 0.5. So T is 2.32. Now the tricky part is to translate this answer based on this scenario. This is the half-life. This is how many half-lives it takes for titanium-44 to decay. So it's taking 2.32 half-lives. Okay, so, but each half-life is 63 years. So if I want to know how many years, I need to multiply this. So 2.32 times 63 is 146 years. So if you want to translate it to years, you would need to multiply it by the 63 because that's how many years it would be based on the 63 half-lives. Does that make sense? All right, so that is our lesson on logs. Be sure y'all practice the homework, and if you have any questions, tune into Q&A session Wednesdays at 1 p.m. And I really appreciate all of your hard work. I can see you working, and I'm excited when I get your questions, telling me a question's wrong on the homework. I know that sounds crazy, but it shows me that you're working and that you're understanding it and that you're persevering in this hard time. So thank you so much. I'm proud of you. Push through. We only have about 4 weeks left. We're almost there.